It takes 10 gallons of fuel to start an M1 Abrams engine, and to move it 1 mile, it burns up to 10 more. That staggering fuel consumption was a byproduct of a very specific historical crisis. By the late 1970s, the joint American and West German MBT-70 tank project had collapsed under its own bloated budget. This left the U.S. military without a modern heavy tank to defend West Germany's Fulda Gap against a potential Soviet armored invasion. Chrysler Defense delivered an answer in 1980 that completely flipped traditional design logic. The newly minted M1 Abrams was built around a single, uncompromising goal: keeping the 4 people inside it alive, even if the vehicle itself was an absolute nightmare for the supply chain. The Pentagon deliberately traded mechanical efficiency and logistical ease for a nearly impenetrable crew compartment, a decision that would shape Western armored doctrine for the next 4 decades. That survivability started with a British innovation known as Chobham Armor. Instead of utilizing solid steel plates, the Abrams used a classified composite array of alternating metal alloys and ceramic tiles. When a shaped explosive charge hits the tank, the extreme heat shatters the ceramics, safely dissipating the energy of the blast before it reaches the crew. And if an incoming round did manage to pierce the armor and ignite the tank's own ammunition, the Abrams had a built-in failsafe. The ammo compartment featured heavily armored interior blast doors and specialized blowout panels on the roof. An internal detonation would simply vent upward into the sky, rather than into the cabin. Moving that heavy armor required a radically different power plant. Engineers fitted the tank with a multi-fuel gas turbine engine, pushing 1,500 horsepower. It drank fuel greedily, but the tactical advantages on the battlefield were undeniable. The turbine produced a nearly smokeless exhaust and operated so quietly compared to traditional rumbling diesel engines that troops in early training exercises dubbed it whispering death. The Abrams secured its place as a Cold War deterrent by pairing this acoustic stealth with the raw power needed to dictate the terms of any engagement. As Soviet armor improved, the Abrams needed more firepower to ensure kinetic overmatch. The military abandoned the original 105mm gun and upgraded to the M1A1 variant, armed with a massive German-designed Rheinmetall 120mm smoothbore cannon. Engineers developed the M829 Sabot Round, a combustible cartridge wrapping a dart-like penetrator. Fired over 5,100 feet per second, the aerodynamic sabot peels away mid-flight. Without explosives, this depleted uranium dart relies entirely on extreme kinetic energy to literally melt through enemy steel. By abandoning traditional explosive chemistry in favor of unstoppable kinetic physics, the M1A1 became an apex predator. That dominance was tested during the 1991 Gulf War, where the Abrams finally faced off against Soviet-built T-72s in the open deserts of Iraq. The technological mismatch was severe. Iraqi tankers had to bring their vehicles to a complete stop just to aim. Meanwhile, Abrams crews utilized advanced thermal imaging and gyroscopically stabilized turrets to accurately track and destroy targets while moving 40 miles per hour in pitch darkness. The result of this technological gap was absolute. During Operation Desert Storm's head-to-head engagements, the U.S. did not lose a single Abrams to enemy fire. But returning to Iraq after 9/11 presented an entirely different threat. In dense urban environments like Fallujah, the tank's speed mattered far less. Insurgents could launch infantry ambushes from rooftops and side streets, exploiting the tank's thinner side and rear armor. The military responded with heavy engineering upgrades. They added the Tank Urban Survival Kit, or TUSK, strapping explosive reactive armor onto the sides, alongside new systems. These additions pushed the vehicle's total weight to a staggering 73.6 tons. To adapt from open desert warfare to city streets, the original vision of a lightweight, highly mobile tank was sacrificed for sheer, immovable mass. Today, the Russo-Ukrainian War has introduced a battlefield dynamic the Abrams was never designed for: the constant threat of loitering munitions and top-down drone strikes. In this environment, intense fuel demands and vulnerability to cheap, overhead drones became a severe liability. After losing 20 of the 31 tanks provided by the U.S., Ukraine was forced to temporarily pull their remaining M1A1s off the front line. The conflict proved that the decades-old engineering philosophy of simply layering on more armor and more weight had finally reached its physical and logistical limits. the U.S. military is now shifting course. Concepts like the Abrams X prototype and the upcoming M1E3 redesign show a deliberate move away from sheer mass. The next generation of heavy armor is expected to feature a smaller 3-man crew, an automatic loading system, and a hybrid electric power plant to cut down those massive fuel requirements. Instead of relying purely on thick steel plates, survivability will depend on active protection systems designed to detect and intercept incoming drones and missiles before they ever make contact. The enduring legacy of the Abrams lies in its engineering architecture, a platform capable of being reinvented for over half a century of global warfare.